Hello everyone. Today I will present the connectivity solutions in Internet of Wearable Things. First, we come to the outline of our presentation. The outline contains terms and concepts, some wearable uses example, wearable IoT classification, connectivity of wearable, architecture of wearable IoT, wearable IoT in edge computing and reference. First, we define some fundamental terms and concepts used in this presentation. The IoT-enabled wearable is smart devices worn as external accessory which embedded in clothing, garments, implant in body, adhere or tattoo on skin that have ability to connect to the internet to send or receive data information for making a smart decision. The wearable IoT is a technological infrastructure that interconnects wearable sensor to monitor human factors such as health, wellness, behavior, and other data useful for quality of life enhancement. The wearable body area sensor is a front-end component of wearable IoT and is used to envelop the body to capture the health-centric data. Cellular IoT define the IoT devices that connect to internet through cellular networks. It provides an alternative to low power wide area network like non-cellular LoRa wide area network or and Sigfox technologies which operated in unlicensed band. The Google search trend shown in figure 1, which is quite old, confirms that there is a growth in popularity of wearable technology and IoT search over the past few years. The emergence of wearable device is giving a new dimension to IoT by creating of body worn or near body sensor communicating with each other or with the internet. We will go through some wearable uses example. The fitness activity tracker share the largest partition of wearable device, followed by the Bluetooth headsets, smartwatches, and web-enabled glass. In gaming industry, the virtual reality and augmented reality headsets are used. In health medical uses, the wearable is quite crucial and the most used is life altering wearable. In sport, the real-time monitoring and biometric data are collected for athletes, players, rehabilitation, and improving performance. In industry, the physically demanding and hazardous environment, such as construction, mining, energy gases, the smart glasses, glove, the integrated camera and audio would improve the workers' safety and their health. The figure 2 illustrates the different wearable for various applications. The related research are categorized in cluster according to their application, and more research wearable IoT application cluster can be seen through 4 tracks such as health, activity recognition and sport, tracking, localization, safety. Beside this main cluster, there are some other research application on wearable IoT devices such as virtual gaming enhancement, payment or education. The wearable IoT can bring endless opportunities in many applications. However, the true power of wearable IoT will be realized when they are integrated into the IoT system. For this reason, most of the existing research papers are connected to the internet in one of the 2 following forms. In the first form, the wearable IoT sends data to the cloud server on internet for future offline processing. In the second form, the wearable IoT device sends data for online processing, and consequently the IoT device will receive some information that help them to operate. Most research works in area of wearable IoT use unlicensed short-range technologies such as Wi-Fi, Bluetooth, basically mainly for users' safety, health, activity, and location. Since the emergence of cellular IoT technology, it has changed the domain of IoT-based technology. The 3GPP release 13 introduced the LTE for machine-type communication and narrowband IoT, suited for wearable, especially sport wearable. The cellular IoT technology has enabled extend coverage, low device costs, and minimize power consumption. Since the power consumption for cellular IoT can be reduced by restricting the bandwidth and the maximum transport block size, operating in half duplex modes, and relaxing timing requirement for hybrid automatic repeat request cycle. These characteristic of cellular IoT had make it a promising technology for providing long-range connectivity for wearables. It can be seen like the smart watches with cellular LTE connectivity are available since 2019, as it come to the market for sport and health purpose. It is expected that later the narrowband IoT will be introduced to watches requiring even longer battery lifetime. Next, we will come to the architecture of wearable IoT. The wearable body sensor, as defined in those first slides, are collecting data either directly from body through contact sensor or from peripheral sensor, providing indirect information of body and its behavior. It is rarely standalone due to the limited computing power and communication bandwidth. Therefore, they need to transmit data to the computing resources, which knows that a internet connect gateway such as smartphone, tablet, laptop, PC, or maybe computing device like Raspberry, which can be seen later, or even remote located cloud computing server. The gateway device comprises of short-range communication such as Bluetooth used for exchange data with wearable sensor, or heterogeneous networks such as Wi-Fi and GSM used to send data to cloud. Some gateway devices have able to store data to run some pre-processing algorithm to evaluate whether the data is clinically relevant and send those useful data to remote server. We won't talk about the cloud and remote server too deeply in this presentation. The figure 5 show the edge computing device, which has a memory for data storage and communicates information between wearable device and cloud. As I said in previous slide, the excessive data from wearable devices can be stored in the edge memory and cleaned for pre-processing. The edge computing device will run light operating system such as Android or Raspbian. The edge will act like an interface between the activity tracking devices and the cloud, and it has a bi-directional communication with both of them. A cloud will receive the data from embedded computing device and run advanced analytics. Finally, we will come to the real prototype of wearable IoT system in edge computing device. As you can see, this is the scheme. The figure 3a show the scheme of the real wearable IoT system in one health application. The MBU 9250, which denotes as MS, is a 9-axis motion sensing device, and the particle photon denote PP, as will act like a microcontroller. Their actual dimension is shown in the figure B, and their pins connectivity is shown in the figure C. These two will communicate based on the I2C protocol, which the serial data SDA and serial clock SCL pins are used by this module to control the I2C bus line. The PP use Wi-Fi network to connect to the Android-based smartphone app that provided by the PP. The app can control the data communication between the PP and the Raspberry as well. The Raspberry has a built-in Wi-Fi which can transmit data to the cloud, and if in the large scale of use in this health system in our house, it can use ZigBee protocol. That and here's all the reference used in this presentation, and that's all. Thank you for your listening.